Okay. So problem: a system of forces acting on a bell crank as shown in figure. Determine the magnitude, direction, and the point of application of the resultant with respect to O. Okay. So first, that's 500 Newton. It is inclined load. So first of all, resolve this 500 Newton load in two directions. Okay. One it is in X direction. Second one it is in Y direction. Okay. So actually, this is towards the point. So it is angle. It is with respect to horizontal. So that's why on X-axis it will be 500 cos 60. 500 cos 60. On y-axis it will be 500 sin 60. 500 sin 60. 500 sin 60. Okay, this is your result. Now calculate magnitude of resultant. Magnitude of resultant. Magnitude of resultant. So for that, sum of all horizontal forces. First of all, sum of all horizontal forces. Sum of all horizontal forces. Sum of all the horizontal forces. So for that assumption it is, and the force it is right side, it will be take positive. The direction of force it is right side, then it will be take positive. If the direction of force it is in left side, then it will be take negative. The direction of force it is in left side, then it will be take negative. Negative. Okay. So Rx is equal to that is summation fx is equal to, or summation fx is equal to, summation fx means sum of all the horizontal forces. Okay. F stand for force and x stand for in x direction. Okay. So first of all, that's 500 cos 60, it is going right side. Okay. So it is positive 500 cos 60. Then minus 700, it is this load, it is 700, it is going left side. Okay. So this 700, it is going left side, minus 700. 700. It will be get Rx is equal to, write down Rx is equal to, so 500 cos 60, 500 cos 60 minus 700. So it will be minus 450 Newton, minus 450 Newton. Okay. Now sum of all vertical forces now. Sum of all vertical forces now. Vertical forces. Sum of all the vertical forces. Okay. And the direction of force it is upward. The direction of force it is upward. The direction of force it is upward. It will be take positive. It will be take positive. If the direction of force it is in downward direction, then it will be take negative. Direction of force it is in downward, then it will be take negative. Okay. So Ry is equal to, write down sum of all vertical Ry is equal to, that is summation Fy is equal to, summation of Fy is equal to, summation of Fy is equal to, summation of Fy is equal to. So first of all, this minus 500 sin 60, 500 sin 60. Okay. So this one it is going downward direction. Okay. Minus 500 sin 60. Then second one it is 1000 Newton. 1000 it is also going downward direction. So minus 1000 Newton. Okay. And third one it is, that is 1200 Newton. So this one it is 1200 Newton. It is also going downward direction. So minus 1200 Newton. So Ry is equal to Ry is equal to minus 500 into sin 60 minus 1000, then minus 1200. So it will be 2633. So 2633 point, it is minus 2366. Sorry, 2633. 2633 point 0.012 Newton. Okay. So now calculate resultant. R is equal to root of Rx square plus Ry square. Root of Rx square plus Ry square. Root of Rx square plus Ry square. So root of Rx square so Rx square, then plus Ry square is equal to root of root of rx square, it is minus 450 square in bracket minus 450 square minus 450 square, then plus ry, it is minus 2633.012 bracket square 012 bracket square. Okay, so it will get resultant of magnitude of resultant from this. Okay, so r is equal to minus 450 square, then plus 26 minus 2633.012 square. So root of answer, it will be 2671 2671.189 Newton. So this one is magnitude of result. Okay, this one is magnitude of result. Now calculate direction of resultant. Direction of resultant. That is tan theta is equal to, so we can say tan theta is equal to ry by rx. It will be ry by rx or summation fy by fx. You can say summation fy by fx or ry by rx. So ry, it is minus 2633.012 divided by minus 450 divided by minus 450. Okay, so minus it will be get cancelled. So tan theta is equal to, it will be get tan theta is 2633.012 divided by 450. So it will be 5.8511. 5.8511. Okay, then theta is equal to, I will write here. Now theta is equal to tan inverse. Theta is equal to tan inverse 5.8511. 5.8511. Okay, then theta is equal to, write down now. Theta is equal to tan inverse 5.8511. It will be 80.301. So direction, it is 80.301. Okay, so this one, it is direction of result. Okay, direction of result. So I will note down r is equal to here, resultant is equal to, it is 2671.189 Newton. Okay, now location of resultant. Now it will be, sorry, first of all calculate movement at point A. O. Movement at point O. Okay, in question it is given direction point of application of the resultant with respect to O. So that's why we will take movement at point O. Okay, so for that assumption, when the movement it is in clockwise direction, it will be take negative. If the movement it is in anti-clockwise direction, it will take positive. The moment it is in anti-clockwise direction, then it will be take positive. Now movement at point O. This movement is point O. Okay. So first of all, write down MO is equal to, so force into perpendicular distance. So first it is 500 sine 60. So perpendicular distance it is up to O, it is 300. So how it is rotating here? So this 500 sine 60, it is rotating. How it is rotating? Here it will be rotating. How it is? it is in anti-clockwise direction. Okay, anti-clockwise direction means it will be plus 500 sine 60 into 300. Okay, so then the second one, it is 1000 Newton. So 1000 Newton, how it is rotating? This one, it is also anti-clockwise direction. So plus 1000 into 150 mm. Okay, then next one, it is, that is 1200 Newton. So 1200 Newton, actually we need this distance. Okay, actually 150 mm it is inclined load. Okay, perpendicular distance it is this one. So just we need to calculate. So adjacent side divided by hypotenuse, it will be cos 60. Cos 60 is equal to, so just assume this distance, it is x. So it will be x divided by 150 mm. So x is equal to 150 cos 60, 150 cos 60, okay. So that's why now second one, it is, that's 1200 Newton. How it is rotating? Is clockwise direction. Okay, clockwise direction, it will be negative. So minus 1200 into 150 cos 60. Perpendicular distance, it is 150 cos 60. Okay, 150 cos 60. I will write down cos 60, it is bottom side. 150 minus 150 cos 60. 150 cos 60. Okay. So then next one, it is, that is this one, it is 700 Newton. So 700 Newton. So perpendicular distance up to this distance. Okay, this distance, it is perpendicular distance. Okay, so now we need to calculate this distance. Okay, so this distance means, so again consider this triangle. So sine 60 is equal to the opposite side. Just assume opposite side, it is y divided by hypotenuse. So hypotenuse, it is, that is 150 plus 150, it is 300 mm. 300 mm. So y is equal to it is 300 sine 60. 300 sine 60. Okay, 300 sine 60. So it will be, how it is rotating? This one 700 cr. It will be rotating. It is rotating anti-clockwise direction. Okay, anti-clockwise direction. So anti-clockwise direction, it will be, considered is plus 700 into perpendicular distance, it is 300 sine 60. 300 sine 60. So it will get moment from this relation. Moment is equal to, now write down, moment is equal to moment at O. Moment at O is equal to, so 500 sine 60 into 300, then plus 1000 into 150, then minus 1200 into 150 cos 60, then plus 700 into 300 sine 60. 300 sine 60. Okay. It will be 371.769 into 10 raised to the power 3 Newton meter. Okay, this one, it is moment at, so you can say it will be summation of moment. So this one, it is summation of moment at O. Summation of moment at O. Okay, this one, it is summation of moment at O. So now application of resultant with respect to O. So now calculate application of moment with respect to O. So application application of application of resultant, application of resultant with respect to O, For that, apply Varignon's theorem. Apply Varignon's theorem. So first of all, summation of moment at O. Summation of moment at O is equal to moment of resultant at O is equal to moment of resultant at O is equal to moment of, cancel, it will be Ry into x. Okay, so this one, it is for, we need to calculate x and y with respect to x and y. So that's why summation MO is equal to Ry into x. So summation M, it is 371.769 into 10 raised to the power 3 is equal to, so Ry, it is how much Ry? So Ry we are calculated, it is 2633.012 into x. So from this relation it will be get x. So x is equal to 371.769 into 10 raised to power 3 divided by 2633.012. So it will be x is equal to, it will be 141.195 mm. Okay, this one, it is x. So now second, it will be summation of plus for second point, summation of MA is equal to Rx into y. Okay, so summation of M, it will be 371.769 into 10 raised to the power 3 is equal to Rx, it is how much? Rx, it is 450 into y. From this relation it will get y is equal to 371.769 into 10 raised to power 3 divided by 450. So it will be 826.1533 mm. So this one, it is x and y value. Okay. So now locate the resultant with respect to point O. Okay, with respect to point O. So I will draw x-axis. So this one, it is y. So location of resultant, actually it is in which quadrant? So both value we have got negative, means it is in third quadrant. Okay, it is in third quadrant. So R is equal to this. R is equal to 267.189 Newton. Okay, so angle, it is 80 point. So angle, it is, direction, it is 80.30. Okay, so next, now distance, it will be with respect to x and y axis. Okay, this one, it is this distance. I will show it is in x and y distance. So y distance, it is y is equal to this 826 0.15 mm. On x distance it is 141.195 mm. 195 mm. Okay, this one it is x and y distance. Okay, this one it is, so this will O point. Okay, so resultant it is with respect to point O, it is x distance it is 141.195 and y distance it is 826.80 mm. Okay, this is your final answer.